In this video, I want to just give you the briefest introduction into the kinds of things you can do with image processing in Matlab. As I say, this is just one example. There's many things that one could do using these tools. So the basic idea is I'm going to take an image, read it into Matlab, pixel by pixel essentially. I'm going to use the discrete cosine transform to convert this from a sort of a time domain to a frequency domain representation. It's a 2D transform. Um, then I'm going to take a shot at reducing the size of the file. I'm essentially going to compress this figure by eliminating some of the less important frequency terms in the transform. Then I'm going to invert it and compare the two pictures. So the workhorse here is the DCT2 command. That's the 2D discrete cosine transform. It's very similar to an FFT, but not exactly the same. And this comes with the image processing toolkit in MATLAB, so you may not have it if you don't have that toolkit. So here's the key. I use the IM or image read command to read in a shuttle picture that I downloaded from the web. I convert it to grayscale using the RGB to gray command. Then I show it to take a look at what the picture looks like before compression. Then I take the discrete transform, and then here's the key. For terms which are small, I just toss those out, saying they have their relative contribution to the quality of the picture is small, and I set those to a small number, 10 to the minus 8. Okay, so the first time I do it, I say, okay, if the absolute value of the transform for a particular frequency is less than 10, then I set it to be 10 to the minus 8. Okay, so then I invert the transform using IDCT2, and then I show what that looks like, and we can compare the before and after pictures. Then I repeat the process, only this time I set the limit to 40. So anything below 40, I set to 0. So now I'm taking even more important frequencies and tossing them out too. So this picture will be degraded relative to the first one, but I'm throwing out more data, so the file would be smaller, or the number of pixels I care about would be smaller. Um, so then I invert that and show it. So let's take a look at the results. First of all, just some numbers. The picture is 480 by 602, so it has 288,960 pixels in it. 180,000 roughly of the frequencies have an absolute value less than 10. So in the first compression, I throw out 180,000 of the 290,000 um, frequencies, and then in the last one, when I throw out more those less than 40, I throw out 274,000. So I'm only keeping what 14 or 15,000 pixels out of 300,000. So there's not much there. If I get a good picture out of that, then I've done quite a bit with compression. Here's the comparison. I hope you can see this. When I just throw out the ones less than 10, looking at my pictures, I can't really tell the difference between these two. If I throw them out terms less than 40, on my screen, I can see the difference. This one is quite a bit more splotchy, and so the picture quality has been degraded a fair bit. I hope you can see that after this has been um, filtered through YouTube or whatever. Anyway, that's basically a demonstration of the kinds of things that the image processing toolkit buys you. There's tools for reading in images, manipulating them, and then showing the effect of the outcome of the change. All right, so good luck.